If integral of sin x by sin of x minus alpha equal to ax plus b times log of sin of x minus alpha plus some constant of integration, can we find the value of a and b? Of course, yes. And we can do it by two methods. If we know how to integrate it, we can simply integrate it. If we do not know integrate, then also it can be done. So we will do it by two different methods. First one, we assume I equal to this integral. You see that we can integrate it easily by going by substitution method. So we let x minus alpha equal to u. If we let x minus alpha equal to u, then x will turn out to be u plus alpha. So we are going by u substitution method, and it will found that dx equal to du. So we are simply replacing x by u plus alpha. Once again, x is replaced by u plus alpha, x minus alpha by u, and dx by du. Now we know the expansion of sine of u plus alpha. That is sine of a plus b, that's equal to sine a cos b plus cos a sine b. Okay, so far so good. Now we know that integral of sum equal to sum of integral, and we can break it, we can cancel sine out, and we will be left out with cos alpha du, and this one we can write it as cos u by sine u times sine alpha. That's just a constant, but we write it inside the integral for the time being, du. We know that integral of cos alpha, that's just a constant, with respect to u is simply u, cos alpha times u. Integral of du is u. What about cos by sine? We can write it as cot, and we know that integral of cot is a log of sine, or we can write cos as d of sine and say that anyway it's log of sine of u. And sine alpha, that's just a constant, so we don't have to worry about it. And of course plus some constant of integration. Now we are initially assuming u equal to x minus alpha. Let's write it back. So x minus alpha times cos alpha plus sine alpha times log of sine of u. U is again x minus alpha plus some constant of integration. But we want exact of this type, ax plus b times log of sine x. You see that b is simply equal to sine alpha. So that's equal to b. How about a? Okay, let's do one more step. We write it as cos alpha times x plus sine alpha times log of sine of x minus alpha. How about minus alpha cos alpha? That's just a constant, so we write it as a constant. So it turns out that a equal to cos alpha, and b equal to sine alpha. As we said earlier, we can do it by another method, so we will do it by another method. Once again, we got the given integral equal to ax plus b times log of sine of x minus alpha plus some constant. By fundamental theorem of integral calculus, we can just change the integral and differentiation, or integral is opposite of differentiation. So we'll just differentiate the right hand side to get the function sin x by sine of x minus alpha. Can we differentiate it? Of course, derivative of ax, where a is assumed to be a constant, is just a, and b is a constant, and derivative of log of sine of x minus alpha is 1 by sine of x minus alpha. We need to apply chain rule. Derivative of sine is cos, so cos of x minus alpha. Derivative of constant is 0. Left hand side we copy as it is. However, the right hand side, can we simplify it? Yes, we take the LCM sine of x minus alpha, and we obtain a times sine of x minus alpha plus b times cos of x minus alpha. We can cancel sine of x minus alpha out to obtain sin x equal to a times sine of x minus alpha plus b times cos of x minus alpha. Somehow we want to determine the value of a and b. If this is true for every value of x, then it should be true for x equal to 0 as well. For x equal to 0, sine 0 is 0, a times sine of minus alpha is minus sine alpha, and b times cos of minus alpha is simply cos alpha. From there we conclude a sine alpha equal to b cos alpha. You may guess that a equal to cos alpha and b equal to sine alpha, but you may also guess that a equal to 2 cos alpha and b equal to 2 sine alpha. So there might be many other possibilities. So what we do is we simply consider this equation. We expand the right hand side. We know that sine a minus b equal to sine a, cos b minus cos a, sine b. The same goes for cos a minus b, that's equal to cos a cos b plus sine a sine b. Now we compare the coefficient of sine x to say that 1 equal to a cos alpha plus coefficient of sine x, so b sine alpha. Again, a sine alpha equal to b cos alpha, so a equal to b cos alpha by sine alpha, a equal to b cos alpha by sine alpha times cos alpha we copy as it is, b sine alpha we copy as it is. Now once again, if we take the LCM, then we find that b cos square alpha plus b sine square alpha, which is just 1 because cos square plus sine square is 1, and we take sine alpha to the left hand side or whatever be it, we simply say that b equal to sine alpha. Once we know b equal to sine alpha, we can write it in this equation and say that a equal to cos alpha. Do we have another choice of a and b? No. The reason being, integral of a continuous function is unique except for the constant of integration.